Hello everybody, I can solve coordinate geometry quadrilateral properties questions by calculating slope and distance and knowing the quadrilateral properties. I don't consider this an easy lesson. It's not that commonly asked, but it's come up enough where I want to talk about this. You need to know your slope and distance formulas. If you don't, then stop right now. Goodbye. Learn that first. You do need to know your parallelogram properties. I guess I should display them. We've got our 5 parallelogram properties. We've got our 2 rectangle. We got our 3 rhombus. 2 pairs of opposite sides congruent. 2 pairs of opposite sides parallel. 1 pair congruent and parallel. 2 pairs of opposite angles congruent. Diagonals bisect each other. Has all the parallelogram properties plus congruent diagonals and right angles. Has all the parallelogram properties plus perpendicular diagonals. Diagonals bisect the angles. Consecutive sides congruent or all sides congruent. And a square has all of them. So you definitely want to know those. Let's get right to it. Actually, let me pause it first. So number 2, if they ever give you coordinates, like there was no graph on this picture, use the graph paper on the readings that's attached to the back of the exam in class if you want it, ask for it. But if they give you coordinates, graph it. It'll make things a lot easier. That's A, that's B, that's C, and that is D. Stretch would be a good idea, but whatever. So it says, first of all, once you graph it, just look at it. Like, what shape is that, man? It's a square. I mean, we could do coordinate geometry and find the distance and all that and the diagonals, but like, it's a square. You don't need to do anything here. It's not going to prove it. And a square is a rectangle. A square is a rhombus, but a square is not a trapezoid. So again, you're kind of just using the properties and your understanding of how they all relate to each other. You're incorporating coordinate geometry into it. This one's pretty simple. You're just applying the points, but it could get a bit more tricky. Let's take a look at number 4 here. It says parallelogram ABCD has coordinates, which would prove it's a rhombus. Well, to prove it's a rhombus, it needs to have one of the 3 rhombus proofs. If you don't know what I'm talking about, then this lesson is not for you. Sorry, that's just the truth. Consecutive sides congruent. Diagonals perpendicular to each other. Diagonals bisect the angles. Coordinate geometry does not do anything with congruent angles, so it can't be that one. So let's see what we got. A is 0, 7. C is 2, 1. And since it's A, B, C, D, I know that AC is a diagonal. So all we have is a diagonal, so I know that the diagonals are perpendicular. It's going to have to be the property I'm going to use, which means that BD is going to have to be perpendicular to AC. So perpendicular lines have negative reciprocal slopes. So I'm going to find the slope of AC. Delta y over delta x. It's down 1, 2, 3, 4, 5, 6. Right, 1, 2. Down 6 over 2. That's negative 3. So the negative reciprocal of that is going to be positive 1/3. So the slope of the other diagonal, BD, must be 1/3. And that is your answer. This is not an easy question conceptually. You have to know the 3 rhombus proofs first of all. based on the fact that it's giving us points A and C, that's the diagonal. So the only property that would apply would be the diagonals are perpendicular to each other. Then you need to know that perpendicular lines have negative reciprocal slopes. Find the slope of AC. The negative reciprocal of that must be perpendicular to it. Is every problem going to be exactly the same? No, but that's the gist of it. Let's go over maybe two more. I'm not going to actually do this problem. I'm just going to talk about it. It wants QRST to be a rectangle. It's giving you Q and S, so it's giving you a diagonal. To prove it's a rectangle, it needs to be one of the two rectangle proofs, right angle or congruent diagonals. Based on the fact that they're giving us a diagonal, we're going to have to use this one. I'm going to find the distance of QS, and RT must be that same distance. So you have to use distance formula. Similar to the previous one we just did, it's just using a different property, but it's the same logic. Let's take a look at number 6. This is a bit different, I think. P is 2, 1. Get the equation. So let's just draw a picture. The diagonals of rhombus team, T, E, A, M, intersect at P. I do it off the grid first just to see what's going on. If the equation of the line that contains diagonal TA is negative x plus 3, what is the equation of the line that contains diagonal EM? So we're talking about the diagonals. I know that the diagonals are perpendicular. And perpendicular means negative reciprocal slope. So if this has a slope of negative 1, my perpendicular line must have a slope of positive 1. The negative reciprocal of negative 1 is positive 1. Negative x plus 3, let's graph that. That's negative x plus 3. So I know that it has to have a slope of positive 1. I know it's got to pass through point P. My y-intercept is negative 1. My slope is 1. My y-intercept is negative 1. And that's my answer. It's incorporating a few different things in here, but the properties remain. And then just use the grid. Again, perpendicular diagonals came up again. Perpendicular lines have negative reciprocal slopes, so we had to utilize that. Again, they're all a little bit different. This is the same type of thing with same type of thing there as well. We can take a look at one more. It says rectangle ABCD. So again, I like to draw it off the grid first. ABCD. A is negative 1, negative 3. B is 6, 5. It wants to know the slope of BC. Well, BC, AB, and BC make a right angle, because that's one of the properties of the rectangle. So their slope's supposed to be negative reciprocals of each other. So I have to find the slope of AB. Whatever that is, BC must be the negative reciprocal. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7. So that's positive 8 over 7. So the perpendicular slope, the slope of BC, must be the negative reciprocal, which is negative 7 over 8. Again, you're using the parallelogram properties, but you're applying coordinate geometry to it. If we're talking about slopes, we use slope formula. Perpendicular lines have negative reciprocal slopes. Parallel lines have the same slope. If we're talking about congruent, that's distance. That's it. Again, it's not simple, but that's how you do it. Goodbye.